Hello everyone. So now we're going to look at summation notation. Alright, so we have this big sigma. So sigma for S, S for summation. Alright, and you have like a formula. So AI is going to be like a formula for a sequence. Okay, so it's going to be given to you. And this is kind of just a general way of explaining. You're summing up, you adding the terms in a sequence. And the sum also needs a lower limit and a top limit. So you say I goes from 1 to n. Okay, so n is going to be a number, right? So you're saying that I starts with 1 and then is going to go to n. So you're plugging in I is 1, I is 2, I is 3, I is 4, I is 5, all the way to that top number. So you're adding A1 plus A2 plus A3 all the way to whatever your last number is. Okay? So that's what, if you see that sum, the big capital sigma of a sequence, it tells you find the first n terms of this sequence and then add them up. Okay? So here's example 12.9. Expand the partial sum and find its value. So this is called partial sum because you're stopping. Sometimes there's an infinite sum where you add like an infinite number of terms. And believe it or not, some of them will have an answer that's not infinity. But partial sum means that this number on top is not infinite. It stops eventually. Okay. So I is 1 to 5 of 2i. So this is like your formula. AI equals 2i. Right? So 1 through 5 means that you want to find A1, A2, A3, A4, A5, just like we were doing before. But what's different here is because you have the sigma, that means add all the numbers up. Okay? So A1 is 2 times 1, which is 2. A2 is 2 times 2, which is 4. Then 2 times 3 is 6. 2 times 4, 8. 2 times 5 is 10. And then sum means that you're adding these up. So we have 10, 20, 30. Okay, so the sum of all these numbers is 30. Right, there we go.